Welcome to the Teja Statistics in paper 6, semester 6. We are having this um, completely randomized design CRD. Okay, so what is this completely randomized design? We are going to discuss. The completely randomized design CRD is the simplest of all the designs, and it is based on the principle of replication and randomization. This design is suitable for which the experimental material is more homogeneous. So, in this design, the treatments are allocated randomly to the all experimental units over the entire experimental material. Let us suppose that we have k treatments. Ith treatment is being replicated ni times. So I equals to 1 to k such that the total experimental material is summation I runs from 1 to k of ni is equals to capital N in capital N. If all the treatments are replicated equal number of times, then the total experimental value is equals to capital N is equals to n into k. N into k. Next, the definition you can see, if the treatments are allocated to the all experimental units randomly over the entire experimental material by using the principles of randomization and replication is called completely randomized design. So, which we already discussed about the uh, randomization, replication, local control. What is randomization? Randomization is a we are allocating the observations randomly. Okay, and replication means repetition of that experiments. Okay, so repetition is will decrease the uh, error values and gives precision value accurately. So for that we are using this one. So what are the advantages of this CRD? A CRD is more flexible since any number of treatments can be used, and various treatments can be used unequal number of times without complicating the statistical analysis. So very simple and easy way here. Next, statistical analysis remains simple if some or all observations for any treatment is rejected or lost or missing for some random accidental reasons. Moreover, the loss of information is smaller than any other design. Next, we have some disadvantages also be. The CRD is can be used only for homogeneous experimental material. Homogeneous experimental material in the sense we have all our equal observations are having the same characteristics. Okay, since the randomization is not restricted uh, any direction, the variations among the experimental units is included in the error variance. So these are some disadvantages. Next, see the application. CRD is most useful in laboratory techniques and methodological studies. In examples in physics, chemistry, and biological chemical experiments, in greenhouse studies, etc. Yeah. In last time, in a last video session, some person got a doubt where we can apply this CRD, RBD, LSD. They asked me that question, and These are the applications which you can see. We can apply in physics. Okay, we can apply in chemistry, whatever. uh, Biological also, and chemical experiment, clinical trials. How the accurate results are giving, is that giving the same or not, we can able to test by using this completely randomized design, CRD. The statistical analysis of CRD. Let's see the statistical analysis of the ANOVA one-way classification, which is very similar to the ANOVA one-way classification. Uh, that is, the linear mathematical model becomes yij is equals to mu plus alpha I plus epsilon ij, where yij is the yield from the jth unit by receiving the ith treatment. Mu is the general mean effect, alpha I is due to the ith treatment, epsilon ij is error due to the chance follows normal distribution, and capital N and uh, K is the number of treatments, Ni is the number of replications of the ith treatment, G is the double summation value of Iij, that is grand total. Next Ti dot and y bar of I dot and so on. Okay, these are the some formulas and notations also. So y bar dot dot overall mean, the variation can be split into the following: TSS is equals to SST plus SSE, which we already know, ANOVA one way classification. Null hypothesis, all the treatments are giving the equal outputs, that is sigma 1 equals to sigma 2 equals to sigma k, and so on. You have calculated values. The test statistic for uh, value, that is f of t is equals to st square divided by sse, that means se square, mean sum of squares values you have to consider with the degrees of freedom k minus 1 and n minus 1. So conclusion, if calculated value of f is greater than the significant value, then we reject the null hypothesis, otherwise we may accept the null hypothesis. Please look at the table of ANOVA, that is CRD, completely randomized design, which is very similar, very close to ANOVA one way classification, and that is also useful for CRD, completely randomized design. Least sum of squares we have to learn very quickly and easily. This is very important for our examination. Yeah, least sum of square. Yeah, this is with respect to the mu error estimate we are considering, and alpha we are considering, and beta j also we are considering. Here we don't have one way model, so alpha I hat is equals to y bar of I dot minus y bar of dot dot, that is mu. Okay, epsilon ij we calculated. Next, expectation of sum of squares. Expectation of sum of squares is plays a very important role. Expectation of eij is equals to 0. Expected value of I bar of I dot is equals to 0. Expected value of epsilon bar dot j is equals to 0, and all. Yeah, these are the some notations, formulas for that calculation. We can see here. Consider variance of y bar of the expected value of y bar of I dot whole square is equals to, we can use the formula mu plus alpha I plus epsilon epsilon bar of I dot and whole square. A plus b whole square we are playing, and we are doing the squaring and summing over. So expectation value of y bar of I dot whole square is equals to mu square plus sigma t square plus sigma e square divided by ni. So keep on doing the calculations. We are applying the expectation, then we will get the value uh, like this. Yeah, you can see variance also. Similarly, the variance also for ANOVA one-way classification. So mu plus summation ni into alpha j divided by n plus epsilon bar dot dot. Similarly, for the treatments, if you are applying, then you will get the value. Okay, expectation value and mean sum of squares values. Expectation sum of squares due to errors also we are going to calculate. Okay, like this. Yeah, if you substitute that mean sum of squares of error is an unbiased estimator of sigma squares. Up to this we had to calculate. Thank you.